Alright, we learned about box and whisker plots. This is part 1. We'll spend 2 days on it. So we're going to construct box and whisker plots, find the mean and standard deviation, find the median, the upper quartile, the lower quartile, the inner quartile range, and any outliers that may occur, and then we'll also describe the distribution of the data. The inner quartile range is the difference between the upper quartile and the lower quartile. We have outliers. You find them by taking 1.5 times this inner quartile range, and then you subtract that number from the lower quartile and add it to the upper quartile. Then you're going to look if there's any data beyond those values. We consider them outliers. The mean, we've talked about this before, is the average of all the values. Standard deviation, we've talked about it as well, and we find it by taking the sum of all the squares of each difference of a data value and the mean, and then we divide that value by the number of data, and then we finally take the square root of that number. So in example 1, we're going to find the median, the upper quartile, the lower quartile, the inner quartile range, and determine if there are any outliers. After that, we will construct a box and whisker. When you are doing this, the first thing you need to do is put your list of numbers in order. So here I've already put them in order. After you've done this, you want to start by finding the median. The median is the number right in the middle, so we can see that 32 is the median, and I like to put a box around that. From there, we're going to identify the lower quartile and the upper quartile. The lower quartile is the median, or the middle value of the lower set of data. So we're looking there. The middle number there you can see is an 18, and I like to put a box around it. The upper quartile is the same idea. It's the middle of the upper values, so we can see that it is 41. Next, we find the IQR, the inner quartile range. We get this by taking the upper quartile, 41, and subtracting the lower quartile, 18, which is 23. And then we're going to use that information to determine if there are any outliers. To determine if there are outliers, we take that 23 and multiply it by 1.5. This will give us a number. In this case, it's 34.5. And we're going to take that number, we add it to the lower quartile. Let me say that again. We take our lower quartile and we subtract this 34.5 and our upper quartile and we add it. Okay, so when we add it to the upper quartile, we get 75.5, and when we subtract it from the lower quartile, we get negative 16.5. Now these numbers become significant because we look now at our list of numbers and we look to see if there is a number below negative 16.5. And since our lowest number is 16, we don't have a number below that. And then we look to see if there is a number above 75.5. Our highest number is 52, so we do not have any outliers in this group. The last thing that we are going to do is we will draw our box and whisker, and I'm going to erase some of this over here to draw our box and whisker. So to draw our box and whisker, you need to decide what scale you're going to go by. I think I'll go by tens, 10, 20, 30, 40, 50, 60. And then to graph your box and whisker, you start with your lowest number, which is 16, and because it's not an outlier, I will include it when I draw my whisker. Then you graph the lower quartile, which was 18. Then we graph our median, 32, and notice I'm using bars on those, and then 41 for the, let me erase that, for the upper quartile, and then we draw our box with those values, and we extend our whisker to that point, and then we graph 52, and we draw our whisker to that point as well. Okay, so B, we're going to do this again. The first thing you're going to do is put them in numerical order. I like to start by finding the median first. The median is the number right in the middle, and I have an even set of numbers here, so it's right between those two. You can either add those and divide by 2, or you can see that 16 is right between 15 and 17. From there, we're going to identify the lower quartile. Lower quartile is in the middle of the lower values, so here it's 14. The upper quartile is in the middle of the upper values, so in this case it's 18. Then we're going to find our IQR. To find that, we take our upper quartile and subtract our lower quartile, which is 4. And then we're going to look for outliers. Remember, to find outliers, we're going to take 1.5 times the IQR, the interquartile range. Okay, so this gives us 6. And then we're going to take our lower quartile and subtract 6. So 14 minus 6 gives us 8. And we take our upper quartile and add 6. So 18 plus 6 is 24. And then we're going to look at our data. Do we have a number that is below 8? No, our lowest number is 13, so we're okay there. Do we have a number above 24? Yes, we do. We have that 44. So 44 is considered an outlier. So our outliers would be 44. Would be listed as an outlier. And I'll show you what we do when we graph this. Okay, so I think I'll go by 5s here. If I could go smaller to include that 44, I would, but 5, 10, should get me there. 10, 20, 30, 40. So the first number that I'm going to graph is that 13, so it's about right here. I'm going to put a dot there. The next number is my interquartile range. It's a 14. Not interquartile range, sorry, lower quartile. Then I'm going to graph my median, which is at 16, and my upper quartile, which is at 18. And extend my whisker to the 13 because it is not an outlier. Now 18 is my only number past, or I should say before my outlier, 44. I can graph that by putting it out here, but I don't extend the whisker to it. So since there aren't any data values between the upper quartile and the outlier, I just put a dot right on my box to show that there is no whisker on this box and whisker plot. Okay, on example 2 we're going to find the mean and standard deviation for the given set. To find the mean, and I'm going to call it x bar, we add all those values and divide by 7. Okay, so when we add all these up we get 227. Divide by 7 we get 32.43. And that is our mean. To find our standard deviation, we use sigma, and that's the Greek letter that represents standard deviation. And to do this, it's quite a long process, so bear with me as I walk you through it. We take 41 and subtract. We take each value and take the difference between that and the mean and square it. And then we're going to do this with the next term from our data. And the next term, which is 52, I'm going to have to carry this a long ways. And then we're going to do this again with our next term. So 18 minus 32.43, 41, 32, and finally at 16. I think you can do all of this step in one process on your calculator. Alright, so when I added these all up, I got 1037.7143, and then you're going to divide by the number that we have, which is 7, and then last take the square root. So when I did all this, I got 12.18, and this number is what we use to call the standard deviation. Okay, so example 3 asks you to take all these numbers and put them in your calculator and construct a box and whisker plot. Okay, so that's what we're going to do, and then once we have constructed the box and whisker plot, we're going to look and see if it's symmetric or skewed. If it's symmetric, we'll find the mean and standard deviation. If it's skewed, we're going to look for that 5-number summary. So we have done this before. Remember that you have to put this in your calculator as a list, and then you need to graph it under a stat plot, and then we'll look at a one variable statistics option to get all this information. So when I used my calculator to graph this, I was given a graph very similar to this. Remember, we call that an outlier, and if you look at our list, we have this 95 that's really out there, so we don't include that when we're going to look at it, and you can see that it's pretty symmetric. Because it's symmetric, we're going to look for the mean and the standard deviation. We could calculate these by hand, or we can use our calculator, which is what I'm going to do. And in our calculator, we'll just go to the stat button, arrow over to calculate, and choose a one variable statistic, and then that will give you your information. It tells you that the mean is 38.46, we're going to round to the nearest hundredth, and that our standard deviation is 22.35. Okay, on example 4, we're going to compare two different sets of values. So you're going to put period 2 in list 1 and period 7 in as list 2. Okay, once you have these listed as list 1 and list 2 in your calculator, you're going to graph them simultaneously. So you'll turn two stat plots on, one with list 1 and one with list 2. And when I did this is what my graph looked like. And then we're going to compare these. We can see that these are both skewed. So because they're skewed, we're going to look at their 5-number summary. Because they're skewed, we're going to look at that 5-number summary. So I'm going to go ahead and write them down. My min for my L1 or my list 1 was 4. My lower quartile, 9. My median is 13. And my upper quartile is 22, and my max is 33. We're going to do the same idea with our second list. And remember, when you choose a one variable statistic, you have to list at the very end L2 by going second 2, and that will choose your L2. So for my L2, my min was 4. So they both had the same minimum. My Q1 was 13, and this is where we start to see a difference. My median was 19. The upper quartile was 21, and the max was 26. So here we can see that right after our minimum, we have a different spread in our data, and we can say here to analyze it. Oh, sorry, I keep writing on there. To analyze these, we would say that our second period or our 7th period minutes are more closely related. So because their data is not as spread out, and we can see that from the scatter plot, that that's what it's asking you to do when you compare. So when you go to compare, I will ask you to write something right here. It says compare. When you go to compare them, I'll ask you to write what you found out by comparing them. Here we would write the 7th period minutes are more grouped together, that they aren't as spread out, and second period the minutes are more spread out. Alright, that should help you with your 6-3 assignment part 1.